Well, let's continue on in the standard library and look at a few more headers. This one is the assert header, assert.h, and it is a diagnostic function. What we do in the program is set assert and then an expression. If that expression evaluates to false, the assertion will be raised. It will fail. So we can have any kind of expression in there, but it has to return a 0 non-true value. You can check on various parameters, see if you've got a file open. These are critical things in the program, because if an assert is called and the assert triggers, the assertion fails, then the program will have an abnormal exit. It will jump right out. This is only used for debugging because this will raise an exception has occurred in the program. Do you wish to debug, continue, send the information to Microsoft? All of that if you're running on Windows. If you're on a Unix Linux system, it will fail out with an abort, the same as if the abort function was called. Files are not closed, locals are not cleared, memory is left lay around, buffers are not cleaned up, you're just dumped right out. So you do not want this to happen in production code. When you compile production code, you'll define the ndebug with a #def, the #define of ndebug. If that is in fact defined rather from the command line or from within the code, then all the asserts throughout the code are ignored. So you can sprinkle these through your code, and when you're in development, it's fine for an assert to hit, fail, or the assertion triggers, and you dump out because it'll tell you what the expression was that came up false, the file that this was originally in, the C source file, and the line number within the file. Now obviously these statements are put inside your code during the pre-processing phase while the preprocessor knows where it is reading your code. So you don't want these things in production code anyway. I'll show you what it does. Here's a little piece of assert code. We pick up the standard IO and the assert.h, and then we're going to assert null. Now of course that is always going to hit, that assert null. So when that does fire, we will be dumped out of here. We will not ever get to the hello world. Now let's go over here and run that. Compile and link, assert.c, which is that file that we just looked at, and then we'll run it, and there we go. Now notice that the command line is telling us this application has requested the runtime to terminate it in an unusual way. Please contact the application support team for more information. Remember, this should not happen during production runs of code. Here's the assertion output. Assertion failed. Null is the word that we had in the assert call. Remember here, right there, null. So it copies out whatever's in there. So that's null. The file was assert.c, which is the only file that we have in this little program, and it was on line number 6. And that's exactly where that assert statement is. Now Microsoft is trying to gather information on programs that do this, so that's where you can send an error report or don't send, and there's various debugging information in there. We could click debug, and that would raise up the interactive environment, the programming environment, and do a lot of other things that we really are not prepared to do here, and allow us to debug the code and see where we are in single step through it and so on, and that's kind of more of an advanced topic. So we'll say don't send, and we're back to the command line, and any kind of memory that we had set aside and all that is would still be floating around out there, but Windows cleans up most of that in the environment, so you shouldn't have any memory leaks or anything if you dump out of assert. And remember that an assert shouldn't be in a production piece of code anyway. So let's come back here, and that's assert. We already looked at the standard arg earlier, the standard arg.h. Remember that that was to produce a variable argument list, and in our little function here, which was called average, we receive a number, which is how many parameters there will be out here, and then the ... the ellipsis, says that there is a unknown or variable number of arguments. We have to call the VA list set up and have a VA list of arguments. So arguments is of type VA list, and VA list is a macro that's defined in standard arg.h. That creates our arguments. We call VA start, and pass it the arguments structure, and the number, which is the last known variable before the repeating ones, or I'm sorry, the unknown list up here. They don't necessarily repeat. It's however many may be here at any one time. Like printf, remember, you could have multiple variables out here and not know how many were going to be passed in. So the num is the last one, so that VA start can find the stack and where these other items might be. And then we can just go through the list with VA arg, and VA arg will pick off the arguments out of this structure one at a time. And then when we're all finished with that, we say that VA end of the arguments, and that will clean up this piece of memory. So that's just kind of a recap of standard arg, stdarg.h.